All right, while you're looking for that,
This guy's seeing better than.
let's talk about the eye.
Do they have 2 sets of eyelids?
Some of them have that nictitating eyelid.
Yeah.
Now we'll have to get to it.
I wish I had that. So when I swim, I didn't have to wear goggles.
All right, so what I'm going to do is we're going to expose the brain. And the reason why we like showing the shark's brain is because it's easy, and it's the only chordate that when you cut down to its brain going dorsal, that you're going to cut through cartilage. No other chordate will have cartilage here. It's definitely unique, but if this is bony, it takes you a lot longer to get it exposed. We'll discuss the significance of that a little bit later. Just taking by tiny steps now. I'm gonna give it to you.
Flexibility, maybe?
It's just not really sure why.
Or the louder.
That was it?
Yeah, well, that version was acoustic. That's stupid.
Just a little bit farther back. All right.
Do they store urea in their muscles? Is that why you
It's
have
all-
to soak
yeah,
them?
It's all throughout their body. Yeah, and what it does is it combats the inorganic salts.
Does it help with parasites?
Maybe, but it's organic salt instead of osmo. It solves its osmoregulation problem.
Nice.
Semicircular canal.
Nice.
So you can see these chambers here. Here's one, and I just pulled it from here. Here's another one on the other side, and then below this you'll have another semicircular canal, and there's another one in there. 3 sets of semicircular canals. Function? Yeah, orientation. I mean, it does apply to movement, but it's really about equilibrium, so that you can move.
You go, don't go, don't.
A little bit more exposed.
Surprised this blade has stayed this sharp down there.
Yeah,
Well,
and
we only order solid equipment in here. We've done this for bony fish brains. Get down to them, cut through the muscle, and it is miserable. All right, just a little bit more. Is there a napkin just right on the other side? No.
Still bleeding, huh?
We'll get some suction. Emma?
A little bit. Unless that's leftover blood from earlier.
Maybe. Oh, we've anybody that wants to cut through this on your own, we've got some sharks in there. Feel free to, because I mean that a lot of what this lab is about is self-discovery. I'm kind of jump starting in here, but I don't think that you'll know all of this just by sitting here listening to me or filming.
You said it doesn't have to be during normal hours as well, right?
No, but I mean, I would encourage you to get in here, and I mean, if you need to cut through this and work back through it, And it is, I mean, we could sit here and I could do this with every bone. But I believe in the philosophy, if you struggle with it, you get pissed off at it, you hate Cody, and then you come back in and keep doing it. And then it'll stick with you. And then you'll love Cody.
You got some fish.
Is there
Are those
class
only
in
good
here
for the
tomorrow
dairy? Those fish,
afternoon?
like, look in the-
You know, I think limnology, is anybody in limnology? Do you have lab in here?
Yeah, I think Tuesdays and Thursdays.
2 to,
2 to 4.
yeah, but y'all are gonna be out.
At 2?
Tomorrow we're
Tomorrow,
gonna
yeah.
We'll be out.
be
Okay.
out. Going to Dunlop.
I think McLean uses this for parasitology as well.
Is that on Friday?
Yeah, I mean, we're in the.
But you can come in here and you can grab your bones. I mean, you can take them up to the lab upstairs. You can take them out on the table. If you're ready to study, you can just politely break in here. But don't tell them I told you could break in here. Act like you did it on your own. Okay. I think we got enough of it exposed here. I'm not going to take it all the way out, but you've got the nares, and this is where it's taking chemicals in the water, and it goes through the nares. There's a olfactory bulb. Yeah, if I do this, we'll see it. This olfactory bulb here is what takes the chemical cues and converts it into electrical cues, stimulus. The olfactory bulb. From here, it runs the olfactory tract into what historically is being called the olfactory lobe. And it's simple, right? The olfactory bulb, tract, and olfactory lobe. But I don't want you to know it as the olfactory lobe. I want you to know it as the cerebrum.
Cerebral.
Because you have a cerebrum, and that is the homologous structure. From here, from the cerebrum, it will go through the skinny portion here is the thalamus region. The thalamus region will have a pineal gland, or an epithalamus is on top. It will have a pineal gland, which is a tiny structure right about here. Usually we tear it up whenever I take off the top of it. Cerebrum, thalamus. From the thalamus, the next lobe back is the optic lobe. And then you have the cerebellum. Let's see here in just a second. If you look, even at the minnows, the smallest of fish, you will see this configuration. This is a big one, but even on the minnows, if we sit there and cut out the brain this big and expose it, starting from the head, from the snout region, you'll see 2, 2, and 1. Bilateral symmetry, the cerebrum, optic lobe, cerebellum. Everybody got that?
Can you point them out one more time?
Cerebrum, optic lobe, cerebellum. If I lift the cerebellum up, break some membrane. You see this little nib right underneath it right here? See where it's coming to a point? That's the facial lobe. These are called auricles. It's a little dog leg or an ear on both sides. That is called the vagal lobe.
Wait, what's the oracle?
The vagal lobe.
Okay, it's the same thing.
So cerebellum, facial lobe, vagal lobe. From here then you have the medulla oblongata.
And there's 2 at this point, one on either side?
Of-
Or no?
there's two vagal lobes.
Okay.
And then they all merge together into one medulla oblongata.
And that's that entire region, right?
The medulla oblongata,
This
yeah,
whole thing.
will continue on until it goes through magnum foramen. At that point, then we just can call it a spinal cord or the dorsal nerve cord. I mean, this is all part of the dorsal nerve cord. But once it goes through the magnum foramen, which is an opening in the occipital, basioccipital bone.
So is your brain just a continuation of the dorsal nerve cord?
Yeah. We'll talk about it. Where the spinal cord ends is about here. But yet we still see that filament. We call this the dorsal nerve cord going through the neural arch. Technically, that is just a process. And it all comes down to what's white matter and what's gray matter. Gray matter is where you have the ends exposed so they can communicate. So where you have gray matter is where thought can occur, memory can be stored. And so is it the spinal cord, is it the brain? It's all the same thing when you have the gray matter. What's down here is just white matter. So it's running out, sending signals to the body and coming back. Gray matter, all of this, it can store memory. One of the things we're missing here is the pituitary. You got to lift this up. Pituitary is going to be underneath the thalamus region. I don't want to pull it up to show you because I want to keep that intact so you can come back and make sure you can identify these structures. One last thing we want to do. And the material is yours. I'm cutting connective tissue. I'm also cutting some muscle because the eyeball can move. And so you've got, see these muscles coming off of it? These are all muscles. And then also what you'll eventually will cut is the optic nerve. The optic lobe is here, and running out from the optic lobe is the optic nerve.
Is that the largest?
Yes, it's the largest. So if we flip this around, notice these are all muscles, and then right there is the optic nerve.